Hello, if you have problem with number bases, please get glued to this video. Today we'll be looking at number bases, and for this topic, it is to teach us that we can actually count in bases other than 10. The default counting is in base 10. Everyday counting is in base 10, and for base 10 we have 10 digits counting from 0 to 9. There's no single digit called 10. 10 is a combination of digits. So for base 10 we have 10 digits counting from 0 to 9. If I want to count in base 8, I'll use 8 digits counting from 0 to 7. And today, for today's class, we'll be concentrating on base 2 called binary numbers. And in base 2 we have only but 2 digits, which are 0 and 1. So if you must do well here, you have to assume that no other digit exists but 0 and 1. So we'll start by converting numbers from base 10 to base 2. That's converting from binary to binary. And we have some of these numbers here. These are numbers in base 10. When numbers are written like this without their bases, it is automatic that they are in base 10. But if they are in other bases, they will be written. It will be clearly written on which base they are expressed. Now, we want to convert these numbers to base 2. Actually, the conventional method is this, and it's easy to understand. Number one, we want to convert 15 to a binary number, to base 2. All I need to do is repeated division. I'll keep dividing 15 by 2, recording my remainder. That's very important. I need those remainders. That is the basis for my answer or for my result. So when 2 divides 15, I have 7 remainder 1. 2 divides 7, I have 3 remainder 1. 2 divide 3, I have 1 remainder 1. And you keep dividing until you have 0. So 2 will divide 1. Of course, there is 0 here, remainder 1. Because actually, 2 dividing 1, it's better to bring it out as a remainder, because there will be a fraction and we don't work with fractions here. So how do you pick your results? You pick your results this way. This arrow going up means you pick the digits from down here upwards. You don't pick from here downwards. But for this particular question, it may not be that clear because everything is the same. So what we are saying is that 15 in base 10 is equivalent to 1111 base 2. And note the way the base is written. If you write the base on the same line with those digits, then you're writing a different thing. It's no longer base you're writing another figure altogether. So 15 in base 2 is 1111 base 2. Now I want to take the second one. The second one is 37. So what do we do again? We keep dividing 37 repeatedly by 2. We are dividing by 2 because we want to express our result or express that number in base 2. So 2 will divide 37. We have 18 remainder 1. 2 divide 18, you have 9 remainder 0. 2 divide 9, you have 4 remainder 1. 2 divide 4, you have 2 remainder 0. 2 divide 2, it is 1 remainder 0. And 2 divide 1, you have 0 remainder 1. Once again, you pick your figures or your answers from the bottom to the top. So the answer here should be 100101 base 2. So we're saying that 37 in base 10 is equivalent to 100101 base 2. We'll also look at this third example, which is 49. We want to express 49 as a binary number. So what do we do? Once again, we'll start our division by 2. 2 divide 49 will give us 24 remainder 1. 2 divide 24 to give us 12 remainder 0. 2 divide 12 to give us 6 remainder 0. 2 in 6 is 3 remainder 0. 2 in 3 is 1 remainder 1. And 2 in 1 is 0 remainder 1. And that gets us to the last part, where we now pick our answers. Once again, don't pick from here downwards, pick from here upwards. So we have 110001 base 2. So what we're saying in effect is that 49 base 10 is equivalent to 110001 base 2. Please, once again, note how you write the base. Don't write the base on the same line with your answers. Alright, we want to look at the aliter to these things. Assuming we want to use the other method, there's another method of converting these numbers actually to binary. And let's see how it goes. 15. Now we will be looking for the highest multiple of 2 we can get in 15. We understand multiples. So, highest power of 2, not multiple. The highest power of 2 we can get in 15. Now, powers of 2, we have 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, in that order. And 2 raised to power 2 is like 2 times 2, 2 raised to power 3 is 2 times 2 times 2, 2 raised to power 4 is 2 times 2 times 2 times 2, in that order. So, for 15, we have, let's see, 2 times 2 will give us 4, it's not up to 15 yet, times 2 again is 8, times 2 again is 16, so this one will not go. Now we stop here. We have 2 raised to power 3. So we are saying we have one group of 2 raised to power 3. Then we move again. Now that 2 raised to power 3 has given us 8, remember we're going to 15. So we cannot exceed 15 and we must get at 15. Now, what else do we add? The next power of 2 we can add. Let's see, 2 times 2 is 4. If we add 4 to this result here, it's still okay because it has not exceeded 15. So let's say plus one group of 2 raised to power 2. So we now have 8 plus 4. 8 plus 4. And that will give us 12. We still need another power of 2. So plus 1 times 2 raised to power 1. But the powers must be descending as it moves. And it doesn't jump. You don't have 2 raised to power 3 and the next thing you will see is 2 raised to power 1. No, it doesn't work like that. But let's see how it goes. We look at the other examples and see how we can work it out, assuming what we have here would make this number will make our result to be bigger than the number we are looking for. Okay, so we have 12 plus 2, it will give us 14. Then the last one is 1 times 2 raised to power 0. Of course, any number raised to power 0 is 1. So 2 raised to power 0 is 1. So 1 times 1 will give us 1. Now, how do we now find our results? All we need to do is pick these figures here. So for here, you start from the very first one. So we have this as 1, 1, 1, 1, base 2. So that's another way of getting or converting 15 from base 10 to base 2. Okay, we look at the second one. It is 37. Now we are looking for the powers of 2 we can find in 37. Up to the 5th power will be there, yes. 2 raised to power 5 is 32. That's 2 times 2 times 2 times 2 times 2. Will give us 32. So we are saying we have one group of 2 raised to power 5. Now, the next power we must write is power 4. Okay, so let's see how it goes. Let's see what we're going to do. Because I know that when we add 16, of course, what we have here now is 32. If we add 16 to it, is bigger than 37. So it means we have just 0 group of 2 raised to power 4. So like I said, you must represent those powers in their descending order. Now, the next power of 2 after 16 is 8, which is 2 raised to power 3. If we add 8 to 32, it will still be bigger than 37. So it simply means we still have a 0 group of 2 raised to power 3 plus. Now, what if we add 4? 32 plus 4 will give us 36. So actually 4 can be there. So we have one group of 2 raised to power 2. We move. Now we have, the next one is 2 raised to power 1. Now we have 32 plus 4, giving us 36. We only need 1. And 2 raised to power 1 is 2, which means here will be 0. So 0 times 2 raised to power 1. That's 0 group of 2 raised to power 1. Then finally, because we must get to the last power, which is 0. So we now have 1 times 2 raised to power 0. It is 1 here because we need to add 1 to 36 to make it 37. And 2 raised to power 0 is 1. So 1 times 1 will still give us 1. And that brings us to the very last answer, which is now the digits we have here is 1, 0, 0, 1, 0, 1, base 2. You can compare with what we have here. So that's the aliter to this. And finally, the third one, we have the number 49. 49. Now let's look at the powers of 2 we can find inside 49. Actually, it is still the 5th power. We can't go beyond the 5th power for 49 because after 32, the next power will give us 64, which we don't have here. So we'll go for, we now say we have one group of 2 raised to the power 5. Okay, that's 32. Let's see, if we add 16, it becomes 48. Fine, that's fine with us. So we are going to say we also have one group of 2 raised to the power 4. Remember, we've added 16 now. So 32, 16 is 48. And what we want to get is 49. Now, you can simply tell that this one will be 0. 0 group of 2 raised to the power 3. Because if we add 8, it will be bigger than 49. So once again, we have 0 group of 2 raised to the power 2. We would also have 0 group of 2 raised to the power 1. Then finally, because what we need to add is just 1, we now have one group of 2 raised to the power 0. So that is it. Because 2 raised to the power 0 is 1. So our answer is now 1. This one here. We have 1 again, which is this one. Then we have 0, 0, 0, and 1, base 2. You can also compare this result with this. Thank you.